Anyway, how are you guys? So how is the conference going so far for you? Very good? Good. So, all right, everything is visible. That's good. So quickly about myself. I am Oleg Zhurakousky. I've been with Spring since about 2007. I left for a little bit, but then came back because we always come back. It's a good thing. So, today I'm going to be, so this is the first time I'm delivering this talk. This is fairly new technology stack that we're working on within the Spring Cloud team. So we're going to talk about serverless. We're going to talk about Spring Cloud Function. We're going to talk about scaling up and down, and we're going to talk about the web and kind of merge everything together. So I'm project lead for Spring Cloud Function and Spring Cloud Stream. These are the two projects part of the greater Spring Cloud portfolio. So quick show of hands, although it's going to be pretty difficult. How many of you are familiar or using Spring Cloud Function? All right, just a few hands, which is great because I plan to show a little bit of just enough to draw your interest in a Spring Cloud Function, but the primary agenda is going to be slightly different. So let's get there. I'm not extremely social person, so I don't have like many different social things to advertise. But yeah, Z Oleg on Twitter and Oleg Z in GitHub. So it's very simple. Here's our agenda. So it seems pretty simple. So we're going to talk about serverless. Then we're going to talk about Spring Cloud Function. Then we're going to bring everything together. And then we're going to talk about web-based workload. So it's almost like we're going to have to take two disparate topics and bring them together and where they make sense within the particular context. So serverless. What is serverless? I bet if I were to ask this question, each and every one of you, I probably would get like 20, 30 different answers. So it's a very sort of a, someone was basically saying it's a pretty bad terminology for what it really is because, I mean, obviously there is a server somewhere. It's just that it's not the server that we typically have to manage. So infrastructure is managed by the provider. So we developers and ops within the company I no longer have to worry about managing the servers, managing the virtual machines, provisioning, and all the other stuff, including managing some of the characteristics of the server, because those are handled by the providers themselves. So what else? Event-driven. So typically, what you're running on the serverless platforms are functionality that is triggered by some type of events, and those events could come from many different sources. So, and the functions that you're triggering are typically short-lived, stateless, so do one thing, but do it well. In other words, not over-bloated sort of applications of the past that many of us, I'm sure, have written. Pay-per-use billing. So another interesting thing, because okay, if I have my own server running, then I'm only paying for electricity, for example, right? Plus whatever I value my time to manage and maintain the server. But if I'm running it with some type of a hosting provider, then whether my application is experiencing a spike or it's idling and does nothing, I'm still paying for the time because that's how the pricing model is set up. In a serverless world, it's quite different because you're only paying for what is used. And this is the essence of scale to zero, because if your application is not used, eventually it will sort of will go into the idle mode, and you have to pay nothing until it's awoken by another event. So scalability, which is again goes back to this whole pay-per-use, scale up, scale down. Again, you don't have to do much of anything to accomplish that, because not like before where we have to create complex cluster topologies. We simply deploy it in that managed infrastructure that managed for us, and it will scale up, auto-scale up, or auto-scale down to zero. And integration with other services. So this is another big thing, which is Okay, so obviously applications are rarely standalone. They interact with messaging system, databases, and many other security and many other things. So typical service providers like Amazon, Azure, Google Cloud, IBM, they all provide integration points with various different facilities that you don't have to worry much about how to integrate this or that with your application. By the way, I typically like, if somebody has a question, don't wait till the very end. Try to see if you can ask it right away, because it's much easier to answer it in context rather than wait till the very end. Although with the light in front of me, it's just very difficult to spot somebody, so only people in the front row will have that privilege. So, okay, so serverless providers. So we have obviously, AWS Lambda is kind of like at the lead right here. Azure Functions would be following, and then Google Functions, IBM, and many others, right? So we'll talk later about what we support within Spring Stack right now. But all of these providers support triggering functions in response to various events. You can see that I put an emphasis on the word triggering, because that's actually quite important. When you deploy functionality, and this actually goes really well with Spring Cloud Function motto that I'll about to explain. Function by itself is just a function. It's faceless. It takes some input, produces some output. It's not aware of where the input came from or where the output goes to. So that responsibility lies within the trigger, or whatever the integration points, adapter, trigger, whatever you want to call it, that sort of wraps this function. So all these providers support that. So for example, like for those of you, how many of you are users of AWS? All right, much more. So obviously, I don't have to explain to you the AWS Lambda relationship with API Gateway, correct? All right. So that's really what I'm talking about. So in other words, the function by itself is just a function, but the way to expose it to the outside world is to attach it to some type of a trigger, so the events are delegated to this function. So, all right, so that's all I have to say right now about serverless. Any questions? Good. So Spring Cloud Functions. So like I said, totally separate topic, and then we're going to bring them together in a few minutes. So it's a Spring Boot-based framework, like pretty much everything else right now in Spring Portfolio, or Spring Cloud Portfolio, promotes the use of Java functions to implement business requirements. Now, this is interesting. So if you think about it, like we've gone through our careers, we designed many interfaces, have written many programs, but realistically, what do our programs do? They take the input, produce the output, or they take the input and do nothing, and just the world stops there, or something gets triggered to produce some kind of an output. Okay, so if you think about it, and with Java 8, so with Java 8, we finally got these three interfaces that really fit well within this model, which is supplier, function, and consumer. Okay? So now if you think about it, what requirement of past, present, or future, it's kind of a rhetorical question, but think about it. What requirement of past, present, or future you cannot implement using one of those three interfaces? None, right? So basically you can always find any requirement could fit into one of those interfaces, because everything we do either takes the input and produces the output, or takes the input, produces nothing, or takes nothing and produces something, right? That's really the nature of what we do. So, but if you use these standard interfaces, then we, the framework developers, can now automatically attach various different triggers, various different adapters to it. So in other words, your faceless function all of a sudden becomes a REST endpoint, or a streaming handler, or AWS Lambda, or something else, and all you have to do is implement Java function, not even a Spring function. There's no such a thing. So Spring Cloud Function is just enabling framework, which you'll see in a second, because I'm going to do the demo. But all you need to do is implement function as a developer, and then this function could be realized in many different execution contexts. So basically, we call it instrumentation, right? So you can instrument these functions in many supported execution contexts, like I said, web, AWS Lambda, streaming, and many, many, many more. So this is kind of what it looks like, trigger plus a function. So Spring Cloud Function wraps Java functions, enabling additional features, such as type conversion, composition, routings, and then it produces also a trigger. So in other words, there is additional feature which we provide with this function invocation wrapper, which wraps the actual function, but what you actually have to implement is just a function. So as I promised, now we get into the demo. So what I'm going to do is, so here's my demo. As you can see right here, it's a very trivial Spring Boot app. And can you guys see the code, or should I make it bigger? All right. So what you see here is that a very standard, for all Spring Boot users, should be no-brainer, right? It's a Spring Boot app which contains just a bean of type function that takes an object of type person, returns an object of type person. I call it uppercase because all it does is uppercases the person's name, right? So that's it. And can you tell me whether it's a AWS Lambda function or web REST endpoint or streaming handler or Azure adapter? Can anybody say? No, it's just a Spring Boot app. It's nothing without looking at the PUM file, right? So let's look at the PUM file and try to discover what, well, before we do that, let me actually run it. All right, I started it, okay? And I'm just going to post to a local host, port 8080/uppercase, okay? And we can see that it uppercased my name to uppercase name. And you can see right here in the console that receiving person Oleg, right? So somehow this function became a REST endpoint, and you really can't see it from the code, right? Well, before I shut it off or even open a maven file, I'm going to go to the Rabbit console. And you can see there is an exchange, sort of queue called uppercase in whatever, blah, 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 right? So all of a sudden, if I, publish message, message published, and I go back in here, and now we see that the message went into the messaging system. I can actually see right here that uppercase out received the output message, and so on and so forth, right? So all of a sudden, this function is also a message handler. How did that happen? Now, like I said, this is what the power of Spring Boot, because when obviously you're already familiar with the fact that when you configure a dependency in the PUM file or Gradle file, those are not just the libraries, those are also auto configurations, right? Which essentially augment the behavior of your code. So let's look at the PUM file and see what's going on there. If you look at the PUM file, it becomes very clear that we have something. So actually, I'm going to comment this out. This is kind of irrelevant. But we see Spring Cloud Stream binder rabbit. So Spring Cloud Stream binder rabbit will pull Spring Cloud Stream, and all of a sudden, your function became a stream handler bound to a RabbitMQ messaging system. What it also is, Spring Cloud Function Web. Oh, because of that, it said, I'm going to export this function as a REST endpoint. So all of a sudden, obviously, it's just a demo. Obviously, nobody wants to use the same function at the same time as a REST endpoint and message handler, or maybe you do, right? The point is that by simply dropping those things into the PUM file, those functions became something else, right? They obtain certain nature that themselves they don't have, right? And the fact of the matter is that you didn't have to change the code. The code that you have written is the same. The unit tests that you have written for that code are the same, but the trigger, the execution context is different, and it's done at the matter of assembly, not at the matter of. So in other words, as a developer, you don't have to know. As the application assembly person, you would. Okay. And before we go back to the slides, I'm going to go to I'm just going to, because obviously with AWS Lambda you have to, I'm going to have to do some deployment and everything else. So, but for the sake of saving time, I already pre-deployed a similar function to AWS console. Again, I can show you it's one of the samples from Spring Cloud Function. This is what I deploying the same, pretty much just a string instead of a person. But the fact of the matter is that it's a Lambda, and I can just go into the test tab, hit test, because I don't really care what the input is, it's a string, and it's a cold start, so it's going to take a couple seconds, and it successfully uppercase the string. So again, the same function, you just saw it being a REST endpoint, a message handler with a messaging system, and AWS Lambda. And I didn't have to change any of the code. Okay? Any questions so far? All right. We're going back to the slide deck. All right. So, but there's a caveat with Spring Cloud Function. And the caveat goes back to the question I asked earlier. How many people are using Spring Cloud Function? How many people are familiar with Spring Cloud Function? Not a whole lot, right? But the reality is, it's not that it's the problem with the project. The problem is that a lot of times that the luxury of greenfield development is not always there, right? So with Spring Cloud Function, we're introducing a fairly new programming model. So that's number one. So you say, if I could do things again, yes, sure, maybe I would use Spring Cloud Function and do things differently. But the reality is you have a week worth of maintaining existing applications that were written either before Spring Cloud Function or without knowledge of Spring Cloud Function, or for whatever other reason, they're not exactly how you want them to be. So you want to make sure that you need to maintain them as well and work on them. And refactoring is not always an option. Another caveat is that, for example, obviously you saw how simple it is to export the function as a Spring, as a REST endpoint. The reality is that people like this functionality so much that we're constantly getting bombarded with requests. Can we do this like Spring MVC? Can we do this like Spring MVC? Can we do that like Spring MVC? The problem with that is that, sure we can. Of course we can. Why? With the code, we can do literally anything, right? The problem with that is that why would we want to compete with our own stack, right? So the reality is that, yes, we provided Spring Cloud Function Web just for the very rudimentary exportation of function as a REST endpoint, but it's not a replacement for Spring MVC or anything that we've done over the past 20 years with regards to web applications. So now we have a dilemma. Obviously, like, okay, how many of you have Spring MVC, Spring Web-based applications currently running? It's funny to say, almost everybody, right? So here's a dilemma, right? So you may enjoy the fact how easy it was to export the function as a REST endpoint, but you all have existing Spring Web apps that you're currently running. And now, with the serverless, with all those promises with regards to pay-per-use, managed infrastructure, all these other things, and what you have. And with the promises of Spring Cloud Function, with its ability to transform your code into various different execution contexts, how can we merge the two together? Like what? In other words, if you think about it, it's like what I'm trying to do is build the case. It's not that can I deploy web app to as AWS Lambda? Of course I can. With some code we can do anything, right? We're developers. The question is not can we, the question is why would I want to do that? And this is why I want to sort of talk a little bit about serverless and then talk about Spring Cloud Function and kind of build a case saying, listen, here's the value here and here's the value there. So now, if I bring this programming model into serverless, then I will benefit with this programming model and on a serverless environment, I will attach all the benefits of serverless environment to this programming model. So now, the question is, can we take can we take existing Spring Web application and realize it in a serverless environment like as AWS Lambda or Azure Functions? And the answer is yes, but let's discuss it a little bit. So, dispatcher servlet, everybody familiar with that, right? if you try to think about the dispatcher servlet function, function dispatcher servlet, do you see any similarities? What does dispatcher servlet takes in? HTTP servlet request, right? And produces, well, not exactly like it, but logically takes the request, produces HTTP servlet response, right? What does function do? Takes something input, produces some kind of an output, right? So there's a similarity, right? So if I if I go back to so you see the slide is similar to the one we saw before, except that the function here was replaced with the dispatcher servlet. So in other words, if I like the way we currently interact with the dispatcher servlet is via HTTP request, that basically by deploying application on Tomcat or whatever, and that's where it runs, right? So we issue network request, which gets converted by the platform into the HTTP servlet request and delegates it to dispatcher servlet. But dispatcher servlet is basically a core routing component within Spring web stack, right? So sure, it's integrated with a variety of web servers because it follows the specification of a servlet API, but it's also a component that you can interact with directly, right? Which kind of, like if you think about it, like if you interact with it directly, then it becomes true serverless thing because, for example, when I write the test cases for this thing, I obviously don't start the Tomcat or anything else. I just delegate this, but talk to dispatcher servlet directly. So, and that's exactly what we're doing here. So we effectively providing an adapter that will bootstrap your Spring Web application, less the server, less the Tomcat or whatever, and now will interact with the dispatcher servlet directly. So the mechanics of it are better seen here. So if you think about it, so for example, and again, I'm using AWS as an example. There's slightly different mechanics in Azure, but again, mechanics are just the implementation details. Logically, it's the same. So we receive HTTP. So in other words, in this example, we receive, looking at AWS Lambda function as fronted with the API gateway. So in this case, we receive HTTP request on the API gateway. API gateway integration within AWS with Lambda is via JSON file, via input stream, output stream. So API gateway produces JSON input stream of that HTTP, of representation of that HTTP servlet request. So now what we need to do to interact with the dispatcher servlet, we need to introduce some kind of an adapter that will convert that JSON request back into HTTP servlet request so it could be interacted with a dispatcher servlet. Because from that point on, the stack right here is entirely controlled by Spring. I don't have to worry about it. All need to, in other words, all the mappings to the path, to all the path variables, parameters, everything is already done for me, so I don't have to worry about this. All I need to do is produce proper HTTP servlet request and invoke the dispatcher servlet. So, and that's what we do. So with Spring Cloud Function 4.03, so right now it's in the snapshots, but 4.03 is going to be released, I believe, next week, actually. So you will actually have an actual release with this functionality, but for those of you who want to try early, it's in the snapshots. I'll include the link to a sample that I'm going to be using right now. But basically, you can now start taking your web applications and deploy them in AWS Lambda and enjoy all the benefits of scale up, scale down, and so on. So back to the demo. So, OK, we can close this. Save. OK. So here's my pet store. As you can see, I'm going to show a little code. There's really just a pretty standard Spring MVC app. There is a, well, we can remove this, but I'm not going to touch it right now just to avoid the demo gods not smiling. It's accidentally gotten there. But anyway, so we got domain objects, we got, you know, typical Spring MVC app with, and again, without looking at the pump file, it's very difficult to tell what it does. Okay. Now let's go back to the AWS console. And so right now I only have this uppercase function, so I'm going to go back to my pet store, and I'm going to use SAM script to SAM. Well, I already built it, so I'm going to say SAM deploy guided, pet store, region, da 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 da. It's going to take a little bit of time, so we're going to talk a little bit while it's doing it. So basically what I'm doing right now is I'm deploying this application obviously with proper dependency in the class path. I'm deploying this application to AWS Lambda together with an API gateway. Okay, so it's going to do its thing. Yes, question?
Can I say that the controller is a collection of functions?
The question is, can I say that a controller is a collection of functions? I believe so, because effectively, let me elaborate. This is a good question. Let me elaborate on that. So in pure Spring Cloud function, we have one of those things we have as a part of the core functionality is routing function. Why do we have routing function? In fact, that routing function was requested by AWS community as well. The point was that because if I have multiple functions and I have to expose them all via API gateway, AWS guys said, we don't want to maintain 20, 30, 40 different API gateways. So what they said, can we have one single API gateway attached to a single function and then have some kind of a header or whatever to route to different functions? And that's how routing function was born. Now, with the dispatcher servlet, as I mentioned before, it's a main routing component of a Spring Web Stack. Routing to what? To path. And path is represented by various different REST endpoints. So with that logic, to answer your question is yes. Dispatcher servlet in this particular instance represented or kind of viewed as a single function that does the routing. Because when we have to do where am I? When we have to do this AWS request adapter, so what are we extracting from the JSON request? We're extracting the path parameters, we're extracting arguments, we're extracting the body, we're extracting all the arguments to construct the proper HTTP request, so the dispatcher servlet can properly route it to a specific REST endpoint, the same way as it would come in with a regular HTTP request running, coming from the actual server. Does it answer your question? Good. Yes? Map HTTP headers to
your object, which is input for your function.
Yeah. So we are good. So another good question. So can it be sort of modified in a better way, meaning that can the mapping be mapped to let's say headers and something like that could be mapped into object? So yes. And I have to dive deeper a little bit into mechanics. So what we're really mapping to is, how many are familiar with Spring messaging, the concept of a message? Okay, so obviously everything internally within Spring Cloud Function, we centralized over a concept of a message. So in other words, we convert everything to message because from that point on, we already have infrastructure within Spring Cloud Function to map things to a variety of different objects and so on and so forth. And we have special signatures, for example, within functions to recognize that, okay, he needs headers, he needs, those type of things. So obviously it's not as sophisticated. For example, if you say, I have an object of type, I don't know, foo, and this object needs to pull a few headers, to be initialized with a few headers, we don't have that yet. Please raise an issue, and so on and so forth. So in other words, not at that level of sophistication, but if you get the message, if the signature of the function is a message, you'll get both the headers and a payload separately. If your function signature, for example, if you're using by function, which we support as well, specifically for the purpose of separating message and header, payload and headers, you can just put input as type of whatever the payload is, and a map, just a regular Java map, and we know that based on that signature, you want the header. So to answer your question is, yes, but not as sophisticated as you might expect today, but could be augmented later. However, because of Spring MVC annotations, if you have sophisticated annotations already in your signature of your method that do the mapping of path variables and everything else, then that's really not us, that's Spring MVC. They do it. So, yeah. All right, so back to the console. So, all right, so now within the Lambda, we have our pet store 17. 17 stands for Java 17. So AWS, like perfect timing, they just about 2-3 weeks ago, they just released the support for Java 17. Otherwise, I would have to show it to you on previous Spring Boot and all the other stuff, so with Java 11. But now it's a newest Spring Boot, newest everything, so to speak, cutting edge, right? So, but before I hit the function, I'm going to look. So here's my result of my execution of my SAM script, and it produced me the URL. So I can just go here, and that's a good sign. It's a cold start. So, and we got pets, right? And if I put some ID, we got a single pet, right? It doesn't really matter what it says, just the request was completed. So request actually went into the API gateway, then into our adapter, then into the dispatcher servlet, and we got our pets, okay? So, questions? Let's quickly summarize what happened. So, basically, we had an existing Spring web app, Spring MVC app, right? All you need to do, all you did is import. It's time to open a pump file. So all you did is imported this dependency, Spring Cloud Function Adapter AWS Web, which itself imports another dependency called Spring Cloud Function Serverless Web. And in Serverless Web, I'll explain in a second. So in other words, you import specifically, because you're working with AWS, you import specifically this adapter. This adapter, this dependency is responsible for that adapter that converts the JSON, that listens to the API gateway request and converts the JSON to HTTP servlet request. In other words, it's AWS aware. It's aware of the format and everything else. Now, what's interesting is that the other dependency, the transit dependency that it's going to pull in, which is the Spring Cloud Function Serverless Web, is absolutely independent from AWS, Azure, or anything else, because it provides the functionality to interact, to bootstrap dispatcher servlet, to bootstrap your Spring MVC application and receive HTTP servlet request and respond with HTTP servlet response. Why is this important? Because first of all, if you look at the adapter code, Spring Cloud Function Adapter AWS Web, you will see that this is really only one class. This function util class is only there because we copied from the Spring Cloud Function core, because quite frankly, even though we're hosting this project, this module within Spring Cloud Function, in itself, it has nothing to do with Spring Cloud Function. It doesn't even depend on Spring Cloud Function core, right? So to avoid creating dependency just for one utility class, we just copy it, right? So literally, the adapter, this module that you just imported into your pump file, is just this one class. And this one class just does what? It basically receives your JSON, creates HTTP servlet request, and delegates it to AWS, sorry, to serverless web container. That's all it does. Okay. Why I'm saying this? Because that means another thing. You can now not just work with AWS or whatever. You can write adapter. You can say, I'm going to receive requests from a messaging system, but I still want to reuse my Spring MVC app. You can do that. All you need to do is write an adapter that will receive your proprietary request and convert it to HTTP servlet request. Obviously, you have to somehow communicate the path and everything else, But again, that's an implementation detail. So that will be known by the particular adapter that you're going to write. Okay. Where to next? We have about 11 minutes. Unless anybody has any questions. All right. So, well, the title of the presentation is scale, right? So let's talk a little about scaling. So, correct. So yesterday, during the keynote, Sebastian has provided a pretty good coverage of this Java initiative called Coordinated Restore at Checkpoint, right? So, and showed a nice demo. So AWS provides its own implementation of CRAC. I still get a kick out of that name, but acronym. But like I had a function called application CRAC. So. Anyway, so AWS Lambda Snap Start, that's the feature of AWS Lambda, and this is basically a realization of CRAC natively within AWS. So it initializes and caches the snapshot of the Lambda. It improves the startup up to tenfold, and we're going to see it right now. And it supports Java 11, and like I said earlier, it's finally supports Java 17. And here's a documentation, a link to documentation for AWS Snap Start, where you can get more information on it. And back to the demo. So I'm actually, to simplify to better time usage, I'm going to do things slightly differently. So I'm going to go to the pet store, and right now, basically, I was executing against the deployed function code, right? So in order for the snap start to work, first of all, we can look at the configuration. We can see that snap start was enabled for published version. That's what they support. So in other words, snap start by default is not available. So you have to have a version of a function to have a snap start. So what we're going to do is we're going to basically create a version of a function and say publish new version. Now, it's going to take, unfortunately, a couple minutes. But I'll talk about what it's going to do. So when that blue turns green, that means it's done. So it's publishing the version, but what it also does is taking a snapshot of the function state where I sort of left it. Okay? So now, you saw when I hit the web page, it took about 2 to 3 seconds. Actually, on average, we can look at later on in a log file, but trust me, it took about 3.5 seconds. That's the average, what I'm noticing with the initial cold start. And then it's like 2 milliseconds, 3 milliseconds, and so on. So now, the question is how quick, like from 3.5 seconds, we need to be times 10, probably somewhere around 300 milliseconds, right? 400 milliseconds. And that's what I expect to show you. This is the reality of doing this type of distributed demos, because unfortunately I have to wait just a little longer for this thing to deploy. Yes, go ahead. Thank you for saving me. I'm sorry, can you please repeat it? Let me see if I understand the question correctly. So in pure Spring Cloud function, we're deploying an application that has multiple functions, okay? So in the AWS case, these functions will be, by default, without anything else. You'll have basically, well, let me think. So, yeah, if you have 100 functions, without any kind of routing function or anything else. Because in AWS, you deploy a single Lambda, right? So in other words, even if your application has 100 function beans, you would have to specify which function name. Remember that when you specify the handler and the function name, you have to specify which function name you're going to use. So in other words, it will only deploy that one. So this is the issue with the routing function. This is why the AWS community requested the routing function, because they want to say, listen, I want to have 100 functions within a single deployment and be able to use all of them instead of deploying 100 different Lambda functions and then maintain 100 different API gateway endpoints. Okay? So, but that's a pure Spring Cloud function. With a Spring MVC, you're simply deploying Spring MVC app. And it may have 100 endpoints, right? But Spring MVC already comes with a natural routing function, which is a dispatcher servlet. So, because you only invoking a dispatcher servlet directly, okay? Effectively, every time you issue API gateway request, it always goes into the dispatcher servlet. And the dispatcher servlet decides which function it has, or which endpoint it has to invoke. Does that answer your question? Oh, thank you. All right. If it's not clear, talk to me after. Because maybe I don't quite understand it. So anyway, we have 5 minutes, which is perfect. Okay, so now we have we created a new version, right? So what I'm going to do is I'm going to test it. And to simplify testing, I've created myself a little, so I created basically, it's another interesting thing. So this is a real sample of a JSON request of HTTP servlet request that comes in when I invoke it via proper HTTP, post or get or whatever, right? So it's just easier, again, it's easier for demo for me to use this. So what I'm going to do is basically paste it here, okay? And I'm going to test, click on test and invoke this function. So again, let's watch the time, and then I'm going to also look at the logs and see the timing. So I'm going to click on test, and it's done, right? So if I click on details, so here we got our pets, breed Dachshund, name Donald, and so on. So the build restore took 150 milliseconds, and the duration of a function invocation took 334, which is pretty much what I would expect, right? And if I click again on the test, it's pretty much instantaneous. And you can see again from the log that obviously there's no restore. You can see that there's no restore field on the screen. There's only duration. Duration is like 3-4 milliseconds. Okay? Now, let's look at the log. All right. So, well, here's the beginning of that interaction. So restore. This is the signal from restore. And now the invocation. So you can see that, let's say 357. We can only look at the milliseconds. We don't have to look at other things. So, and ended at 613, right? That's the end of the request, right? So about 300 milliseconds, right? But we can also see that in a subsequent request, it went from 683 to what, 685, like 2 milliseconds, 2-3 milliseconds. So which also is kind of expected. So there was, because the snapshot was preserved during the function deployment. So now if I had a luxury of sit here for another 30 minutes and let this function, this version die naturally, the snapshot that would be preserved would be with already pre-initialized dispatcher servlet, which means that we would basically have restore time, which was what, 1.5 milliseconds, and the actual invocation time of 2-3 milliseconds, right? It would be literally instantaneous. Okay, so we're pretty much wrapping up. So just a couple more slides. So currently, we support, for this functionality, for this initial support of deploying web workloads, we support AWS Lambda function, obviously, and Microsoft Azure Function. Other platforms, as I mentioned earlier, would simply require adapters. And again, those adapters are not limited to the web stack. You just said with the web stack, the translation of that proprietary request to HTTP short request is very straightforward because you're just looking for the fields that represent the same fields in HTTP short request. If request comes in from somewhere else, then you have to basically think about how you're going to do the mapping and so on and so forth. But once you figure that out, it's just a matter of writing code that translates your request to HTTP servlet request. And for that, we provide that translate module that I was mentioning before, where you can simply create. We provide implementations of HTTP servlet request, HTTP servlet response, where you can set parameters, right? They're all called proxy HTTP servlet request, proxy HTTP servlet response, proxy session, proxy this, proxy that. So what's next? So like I said, we're going to enhance the current support within current Spring Web Stack, and obviously start providing, based on the community demand, start providing various different adapters to convert those type of proprietary requests to HTTP servlet requests, so you can reuse your existing Spring MVC apps or Spring Web apps basically reuse your existing Spring Web apps in whatever execution context you want. Now, another thing which does right now scale to 0 and scale to whatever is Microsoft Azure Spring Apps, which again, I just included the slide for information purposes. There's a link where you can get more information for that. And with that, the tools we were using today was Spring Boot and Spring Cloud Function. Here's the link to the sample application, and thank you so much.